Hello everyone, my name is Majd Assaf. I am a communication engineering student at Princess Sumaya University for Technology. Today I'm going to talk about microwave engineering classes. Especially I'm going to talk about a very important topic, which is the impedance matching networks. But at the beginning I will talk about the benefits of impedance matching and the meaning of impedance matching. The meaning of impedance matching is that the generator sees a gamma equals 0 if we look toward the load. And the first benefit we get from this, Zs equal to Z0, which is the characteristic impedance, and that means the transmission line is independent of the line length and the frequency. And by doing the impedance matching, we get a maximum power transfer to the load, and SWR equal to 1. That means no voltage peaks on the line and no bounces or echoes. But what if we can't get the load equal to Z0, the characteristic impedance? So at this point we need to build a matching network so that the source effectively sees a matched load. So in this video I'm going to solve an example which have the ZL equal to 10 plus J10 and Zs equal to 50 ohm, which is equal to Z0 50 ohm. And to solve this example we need to use a program tool which is GitHub program, and this program is made by students graduated from our university. But at the beginning I will get the normalized value for the impedances for ZL and Zs, and to get the normalized value we need to divide it by Z0, which is the 50 ohm. So normalized Zs will be equal to 1 and normalized ZL will equal to 0.2 plus J0.2. So now we go to GitHub program and import the Smith chart as we can see it here. And now we locate the points of ZL and Zs. So the ZL is equal 0.2 plus J0.2, so the R circle equal to 0.2 and the X circle is equal to 0.2. So this is the 0.2 R circle and the X equal 0.2 circle here, so the point will be here. And for Zs is equal to 1, so the X circle equal to 0, which means this line, and for 1, which is the original of the Smith chart. So the ZL will be equal here ZL equal to 0.2 plus J 0.2 and Zs is equal to 1, which is equal also Ys, the admittance. And to build a matching network we are going to need to move from point B from ZL to the Zs by constant R circles or constant G circle. So to move from ZL to Zs we need to move a constant R circle, which is the R equal to 0.2, until we get to the G equal 1 circle. So as we can see we are moving like this and then like this. I will draw it by the pen. We are moving R equal 0.2 until we get this point, and then we are moving a G equal 1 circle until we achieve the Zs. As we can see we switch the move at this point, so I will find the impedance of this point and the admittance of this point. So this point I will call it B, which Bz equal to, as we can see here, the R equal 0.2 and the X equal 0.4, so it's 0.2 plus J 0.4, and the admittance is equal to 1 plus or minus J2. And the reason of moving constant R circle or constant G circle is that we are just adding a series inductor or parallel inductor or the capacitors, so that to get the value of the inductors or the capacitors at the beginning we need to see how we add it. So in this law we can see here that if we are moving a constant R circle in the direction of clockwise, we are adding a series inductor, and in the direction of counterclockwise we are adding a series capacitor. But if we are moving a constant G circle, we are adding a parallel capacitor in the direction of clockwise and a parallel inductor in the direction of clockwise. And to get the values of this inductor or this capacitor that we find it, we are going to subtract the impedances or admittances of the source that we are moving from the destination we are moving for. So in the Smith chart, as we can see, we are adding here for the first line we move it, we are adding an inductor, and at the second line we are adding a capacitor. But in the first line we are adding a series inductor because we are moving a constant R in the direction of clockwise, and we are adding a parallel capacitor in the second line because we are moving a constant G in the direction of clockwise. And by getting this value, so we are going to subtract B of Z minus Z of L, so we get the 0.2 minus 0.2 equal to 0, and J.4 minus J.2, so the inductor will be J.2. And at this point we are subtracting the Y of S minus Y of B or B of Y, so we get 1 minus 1 which is equal to 0, and 1 minus minus J2, so the capacitor will equal to J2. So as we see, we get this matching network at this picture, like we are adding a series inductor with the value of 0.2 J, and we multiply it by 50 because it was normalized, and the C is equal 1 over J2 times 50 because it was normalized in the Smith chart, and also we put it 1 over the answer because it was an admittance, so this will be an impedance. So now the generator will see a gamma equals 0, so the load will be matched to the source. And now I need to thank you for listening and wish you the best luck.